Okay, good morning. Today I'm going to show the difference to solve a first order ordinary differential equation dy dx equal to x times y using Maple and Python. Okay, for example, I show you the in Maple. We start. Then I would like to plot the solution later on, so I call the with plots in Maple, and then I will define the ODE. In Maple, make sure it's colon equal ODE. So the ODE is dy dx equal to x times y. So d dx, we must have the y function of x. Dy dx equal x times y as a yx. Okay, so this is in Maple. If in Python, you got to import the maxplot library.py plot as a PLT, import the numpy as an NP from the scipy.integrate import ODE. This statement, if you want to do numerical, if the ODE doesn't contain any analytical solution, then you use a numerical techniques. So this one we can, and then might we include it. Then you okay. Um, when you get my Python file, you can actually save a copy in your drive, and it will be saved in the, it will, okay, if you first time have your Python coding, then you save a copy of ODE in actually in the Google Drive, My Drive. It will be create a collapsed notebook folder and will be in here, copy of ODE here. And then you can open, you already open, and then you can modify it to the name that you want. So okay, this is in another folder. This is once you save a copy, it will create Google under the collapse notebook, and then with a copy of ODE, and then you can save, can modify, click the name here, change it to any name that you like. And then if you want to run here, you can actually, all the coding here, you can actually create run all. It will run everything, or you can run block by block to see the result one by one. So we see scale here in Maple. To define the ODE, it just use in a calculus template, the ddx, the f change to yx. Our ODE is dy dx equal to x times y, so x times yx. So in Python will be similar to MATLAB, but MATLAB you got to buy the license. Python is freeware. So what I mean, in Maple will be suitable for symbolic. You no need to define the variable x and y because it's suitable for symbolic. But Python and MATLAB, you need to define x and y. Define them as a symbol. X is a symbol, uh, the bracket comma x, define y as a function y. Okay, and you see the ODE in a Maple will be easy to define. It's like natural display in mathematics, but here will be like a DOS based. MATLAB also same thing. Okay, you need to define the symbol. MATLAB have its own syntax, Python its own syntax. So here ODE in a Python, you can name it as ODE or any name that you like. Here I name it as diff underscore EQ. Okay, this one is up to you to name it. You can name it as ODE, or this is capital ODE or lowercase ODE. Both Maple and MATLAB are case sensitive, so capital and the lowercase are different variable. So to define the dy dx, dy dx is here. Okay, you got the whole thing, everything EQ equation. Then yx dot diffx. Okay, this stands for the dy dx, and then to equal the comma. So the same thing, y must be a function of x. Same thing with the Maple. So multiply is here, the asterisk times x, closer here. So this is actually dy dx is equal to x times y. And you print and I execute this one. You see derivative of yx okay, respect to x, and then equal to x times y. Okay, and then to solve the differential equation, if the differential equation contains of analytical solution, okay, then you can solve it. Okay, this is general solution, so I put general solution in mapper colon equal. You see mapper colon equal in Python or MATLAB is only equal. So each so each software or each mean the mapper, okay, or MATLAB or Python, they got their own syntax. So general solution, but they still the same thing, dsolve, dsolve, dsolve. All right, I want to solve my ODE, okay, ODE, okay, solve for the y, right? So yx. So the general solution is okay, if first order you have one constant, so constant, let's say this is c exponent half x squared. Then you see the Python also, okay, dsolve the differential equation, okay, display the solution. I print the general solution colon, so y equals, so this will be the string, the okay, solution dot RHS. I just want to display here. Okay, if I don't have here, you see they give you equation yx mean here. So it make you confused. So I just show the right hand side. And you compare here. Okay, and then if you, so now here, so C1 exponent. So you see in Python exp, like Excel also. Okay, x, the power is x. You have a x squared. So x multiply x multiply x. So x start asterisk 2, and then divide by 2. Okay, if you want to get particular solution, so particular solution will be dsolve. Okay, you see if I put ODE, it will give you what errors there, because it's case sensitive. Let's say y0 equal 1, and you see what happened. Unknown. So you see this is capital, this is lowercase, so it's case sensitive. So the particular solution, when you solve, actually the C1 is actually 1. So we get particular solution is exponent half squared. Okay, you see here the particular solution. The same thing to get particular solution. So inside the dsolve differential equation, comma, you must have ICS equal initial condition here. Okay, this one up to you to change. This is variable that you define by yourself. So comma, so the okay, this parenthesis y comma 0. Okay, you see in Python is colon 1, but in Maple is equal 1. Okay, okay, so it says okay, both Maple and Python give you the particular solution, exponent x power 2 divide by 2. Okay, and if you want to plot these solutions, you want to plot this solution, that's why I will call with plots. Okay, you have okay the plot ODE plot. Oh, I never use ODE plot. Okay, I will use plot. Okay, I just want to plot this one, exponent half squared, so I will plot. This is okay called as a particular solution. This is the right hand side of this particular solution, so RHS of this particular solution. Okay, when you plot, so I must define my x. Okay, let's say x from -5 until 5. So you get this is a particular solution graph, mean exponent half x squared. Okay, How about in Python? Okay, in Python, you see here, all right, since just now we run everything, already have the answer. So or you may click one by one to run it. So why functions? So the same, okay, you see in Maple we RHS bracket particular solution. Okay, and then in Python, okay, I call solution. Okay, or I call this is, okay, I can rename it particular solution like this. So this will be particular solution. You see. So all the left hand side is actually the variable up to you to define it. So now I call this particular solution, and then I will particular solution dot. So the right hand side of this particular solution mean exponent. Okay, half of x power 2 I'm going to assign to a y function. Okay, and then so you see in Maple to plot, you call here right hand side of this particular solution, and then so you call the plot. Okay, it plot x from -5 to 5. Okay, but in Python or MATLAB, you got to define the x value. Okay, x value. Okay, numpy is actually when you have do all mean you got to here in Maple just straight away -5 to 5, but in Python I got to call numpy dot linear space. Okay, here -10 to 10, or you want -5 to 5. So mean they will generate, okay, a random mean a number in between -5 to 5. So 100 is actually, or you just want mean how many, okay, point in between -5 to 5, mean the increment here -5 to 5. So inside -5 to 5 total I got 100 point there. Okay, and then the y value, okay, you see I think Maple will be easier, you just plot this thing. But in Python, y value, okay, y function is actually the exponent half x squared. You need to dot substitute x value, and we need to substitute all this value, mean you need to substitute all the value into the y. Okay, hence then y will be contents of value, then you can plot it. So you see a bit tedious, okay, if you use, okay, MATLAB or use Python. So y values, okay, this is a, okay, syntax, the square bracket y underscore function. Okay, y underscore function, because the substitute the x comma value dot eval f for all the value in x value. Mean it's actually we put out all the x value in the y function, then y contains value. Then now, okay, plt, okay, is for plotting. That's why here we must import all the library. Import max plot library dot py plot as plt. Import this library, call it as plt. Okay, plt. So dot plot, okay, so you compare when you plot their syntax. If in Maple you plot, this is a function. Okay, for example, I plot x, and mean my function is y equal to x, x from -5 until 5. uh, so but in, okay, Python, they plot the x first, x value, okay, x value from here, y value is here. Okay, and the label, yeah, mean the label here, this one, the label mean the legend there. Okay, and the x label, okay, here plt.x label, here x mean label x axis as a x here. Okay, the y axis here as a y. Okay, the title here, particular solution of dy dx equal to x times y with y0 equal to 1. Okay, the legend, so we show this particular solution, the grids through plt show. Let me get this thing, we modify to -5 to 5. How you see both uh, Maple and Python give you the same solution. But for me, for symbolic, I will prefer using Maple rather than Python or MATLAB. Python and MATLAB will be suitable if you have a numerical, numeric key. Or you need to run the simulation with the numerical values. So it will be faster if you use Python and MATLAB compared to use Maple. Maple is suitable for symbolic. And then if you compare Python and MATLAB, Python is a freeware. MATLAB, you got to buy the license, and Python is and actually all of MATLAB is follow the trend of Python. Python is freeware. You can get all the coding easily, okay, easily. Or even though you cannot do the coding, you ask ChatGPT, it will help you to code it. If you got error, you ask ChatGPT, it will help you to fix the errors there. Okay, mean MATLAB is actually follow all everything, mean follow the trends from Python. Somewhere Python is freeware. So in university, maybe you got university buy the license for MATLAB, but when you go out to works industry, they may not, okay, able they may not afford to buy MATLAB. So industry people will use Pythons. Okay, so I will attach the link for the code so you can have a look. Then you can just change the, okay, the differential equation here according to your equation, and then you may change, okay, your initial condition here, and then you may change, okay, the x range, okay, and then you can change mean the title here for your own problem. Okay, with this, thank you for your attention.